Hello, welcome to AQA demola. In today's lesson, we are going to be covering the halogens. So, group 7 on your periodic table, we're going to talk about their properties, reactivity, and displacement reactions as well. So, should be quite interesting. Let's get into it. Okay, so group 7, we are talking about the halogens. And again, really important, know where these guys are on the periodic table. Literally, this group 7 highlighted in yellow. Yeah, those are your halogens. Now, what do you know about group 7 of the halogens? Well, all of them are diatomic. This is a really important point. All of them are diatomic. So they exist as I2, Cl2, F2. Yeah. And if you keep down the list, it's always two of them. Yeah. And they all are non-metals that form 1 minus ions. So they gain a single electron when they are reacting. Right. So when you're drawing your ionic equations, you have to remember these are diatomic, right? So F2 going to gain an electron to form F minus. But because there's 2F2, we need to do plus 2 minus, going to form 2F minus. Hope that makes sense. Yeah, and similar thing with chlorine. And what I also wanted to show was the electron configurations. So see for chlorine, I've written it out here. For chlorine, we're going to fill it up like normal. So 1s2, 2s2, 2p6, 3s2. And then if we're adding up all the electrons in chlorine, total is 17, meaning that it's got S2p5. So you'll see with all of your halogens, they're all going to be S, not in the highlighter. You can see it, all of them are going to be S2p5, right? And we've drawn the shorthand there. Now, with the ion, it's going to be quite similar, but as we know, it gains an electron. So you can see this electron in red has been added on here. What I also wanted to emphasize is when you're doing the shorthand, go for NE, so neon, 3s2, 3p6, not just the next noble gas. Right? I think that's quite an important point to remember. You kind of want to draw it out like what I'm about to box off. You want to write it like that, not the other one. Hope that makes sense. It's a brief introduction to your halogens. Okay, so we've done this dance before really with trends, but it's very important to just make sure that we're still on top of it. Alright. So melting on boiling point is going to increase down the group. Why? Well, all your group 7 elements, the diatomic, they exist as simple molecules. That's a really important point. That all of them are existing as simple molecules. Yeah? If we have more electrons, it means you can form stronger London's forces, stronger induced dipole, whatever you want to call it, we're forming stronger. So we need more energy to break them. Yeah, we've kind of gone through that before. Reactivity, again, it's a trend that we have talked about before. As you go down the group, there's going to be more shells. We increase the atomic radius, so there's more shielding. Those are 3 very important points. So if I see if I'm an examiner, I see more shells, they know the atomic radius is increasing, they know there's more shielding. Yeah, that tells me that you know what you're talking about. And then what we're going to say is that means that the attraction from the nucleus on the outer shell is weaker. And if that is the case, then it's going to be more difficult to attract an electron, to gain an electron, to form that 1 minus ion. Right? So as you can see here, we have 2 molecules, both halogens, both have 1 electron, both have 5 electrons in the outer shell. So they have 7 in the outer shell. They have 7 in the outer shell. So we have 7 in the outer shell. But this one here that I've put the tick next to is going to find it much easier to get that electron in because the distance between the nucleus and the outer shell is less compared to this distance. I hope that makes sense. Something as well to be aware of is your halogen displacement reactions. You'll see here that in terms of reactivity, like we said, it decreases going down the group. So chlorine is more reactive than bromine, which is more reactive than iodine. Yeah, fantastic. And the halogens can displace each other. So if we draw a simple equation and an equation here, if I'm adding chlorine to a bromide ion solution or like potassium bromide, the chlorine is more reactive than bromine, right? So chlorine is going to displace bromine. Yeah, so chlorine comes, it forms KCl, and then you get bromine on the side. Yeah, we can draw the ionic equation for that as well. Cl2 plus 2Br minus goes to 2Cl minus plus Br2. And that's because they are aqueous, or they're in solution when they're with the potassium. Now, what you should know is that, okay, iodine, is it more or less reactive than bromine? It's less, right? So it cannot displace bromine from solution. It cannot. And that will be the same if you react bromine or iodine with a chloride, or if you react, that's kind of the only other scenarios. Yeah, cool. So you need to know the color changes as well. So chlorine, pale green or colorless, doesn't really matter if it's organic or aqueous. Yeah. On the left here, I've got the answers for an aqueous solution. If it's aqueous, bromine will appear orange and iodine will appear brown. Quite similar colors. I wasn't a fan, but quite similar colors. But if it's organic, here's where you get more difference. Bromine is yellow and iodine is purple. So just make sure that you know what solvent are we dealing with. Are we maybe dealing with something like cyclohexane, which is an organic solvent? Then you'd get the two colors on the right. If you were dealing with an aqueous solution, then it's going to be the two on the left. So if you wanted to know, for example, in example 1, where we had chlorine reacting with a bromide solution, we'd form an orange solution. And we're forming that because bromine's displaced. So bromine's here, it's been displaced. That's what's in the solution. Whereas in example 2, it would remain brown. Right, sorry, no, bun that. It wouldn't remain brown. That's incorrect. Apologies about that. It wouldn't remain brown. It would be... Oh, no, sorry. Sorry, it's a late night. It is brown. It stays brown. It stays brown because iodine is brown. Ignore that little mess up that I had. It stays brown. Cool. Just be aware also for tests of halogens. We will cover this in a bit of a later video, but I just thought it was good to know. You're reacting with aqueous silver nitrate and a precipitation reaction will occur. So a chloride precipitate is white, bromide green, and iodide is yellow. Hope that makes sense. Okay, so we've got some questions to try. We've got this bit of a longer one about halogens, and you'll need to explain the trend in reactivity. Then we've got another one, 2 parts to this question. We're going to say that chlorine reacts with sodium hydroxide, and it's going to give you bleach. So if you could write an equation for that and the conditions required, and then also underneath that, you need to explain what a disproportionation reaction is and show it's happened. So I'll zoom out again so you can see both questions. Have a good go at that, and we'll go through all the answers. Okay, so we're going to go through some answers now. So, they added bromine to a chloride and they also added it to an iodide. Now, what we're going to say is that the orange solution was bromine. I know I said it was yellow in the other slide. That's still not false, right, in an organic solution. But what it's really getting at is that bromine cannot displace chlorine, so there's no reaction. And then the violet one, bromine did replace iodine, which is why a violet solution formed. Drawing your ionic equation, again, we hope it's not too difficult, but you can see here, we had bromine in solution replacing iodide ions. So it's now bromide ions and iodine. Yeah. Reactivity as well, we talked about this. We've talked about this in extensive detail, where you're going to want to talk about reactivity decreases, fine, because it can gain electrons less easily. Thankfully for you guys, they're not actually asking too much. I mean, more shielding, more shields atomic radius as well, and then lower nuclear attraction. So those are the kind of important things that you want to say when you're answering a question like this. Now, in terms of bleach, I'd say it's almost good to kind of know an equation like this off by hand. Even if it's like NaClO3, which is another one, I think that's a really good thing to just memorize this whole equation, because disproportionation reactions are difficult if you don't know the reagents. Cold and dilute. What happens? The sodium hydroxide has to be cold and dilute, and then you can form bleach. Now, in this part, define disproportionation. Fine. Assign the oxidation numbers as well. I think would have been fine. Then you just need to say what happens. If chlorine's been oxidized from 0 to +5, and it's also been reduced from 0 to -1, then that means that this must be a disproportionation reaction, because one element has both been oxidized and... Okay, and as always, we're going to end it off with some A-star tips. So, what's good? Identifying halogens on the periodic table, all in group 7. Being aware of the color changes that happen in organic and aqueous solvents. Very difficult to remember and easy to mix up, but just remember, the color changes tend to be a bit harsher when you're on organic, so like, you're getting yellow, you're getting purple. But all of them are quite similar with the aqueous, where you're getting brown and orange, right? Now, you need to be quite confident with the ionic equations as well for halogen dissipation, disproportionation. These are questions that come up in most years. And then be able to explain the trends in reactivity and melting and boiling point. Although I think you did that quite well anyway, but just good to always have a refresher. What's bad? What's not to do? Confusing color changes in the organic and aqueous solutions happens so much, where it's an aqueous solution, if you've read the question, and someone's like, oh, I'm not on today. Yeah, and then you just know that they probably are. But again, it's not monitored attendance, so it's probably fine. Don't take that from me. And then also with chlorine treatment, we didn't talk about it that much, but you would get a disproportionation reaction. Just be aware. They'll ask you about benefits of it. So I would say about killing bacteria if you're treating chlorine with water, and then what's poisonous. well, what's negative is that it could be poisonous, like I feel like a lot of people feel that way, but it's not on our place to comment, to be fair. Either way, I hope that video has been quite useful. If you have any questions, drop them in the comments below and I'll do my best to answer. If you enjoyed the video, liked it, felt like you learned something, please like and subscribe to the channel. We've got the Instagram and the TikTok both at A Star Demola, and I'll catch you in the next one. Goodbye for now.